Think of winter, think of white. Of summer, green. But who can limit fall to a single color? When the summer wind blew against these trees, the green leaves danced in the sun's warm light. But now the dance of the leaves is ending. The dancers are leaving the stage. The curtain comes down on summer. In brilliant costume, autumn appears. To farm people, autumn means more than glorious colors. On the farm, autumn means the ripe field, the full crib, the bursting bin. From man's earliest days, harvest time has been the gladdest time of the year, the reward for the long, hard work which begins as soon as the earth has waked from winter slumber. But today's abundant harvests celebrate not only the labor and skill of the farmer, but the contributions of men who are equally indispensable to 20th century agriculture, scientists. The harvest we reap today is a harvest of science and of the farmer's willingness to apply science to everyday agriculture. The application of science to agriculture is not new, although the greatest progress has been made in recent years. Naturally enough, science first turned its attention to our greatest resource, the soil in which our crops are grown. Dr. M.B. Russell of the University of Illinois examines plots which show how corn yield differs with rotation and soil treatment. This plot has been planted to a corn oats legume rotation and treated with manure, limestone, and phosphorus. A 4-year average yield is 101 bushels per acre. This plot has been continuously planted to corn since 1876 with no soil treatment. Yield is down to 15 bushels. The greatest single limiting factor in American agriculture is a deficiency of nitrogen, from which these plants are suffering. More and more farmers are using legumes in their rotation. Soil testing is the only accurate way to determine what elements the soil needs and what elements it already possesses in sufficient amounts. With the soil tested and its deficiencies known, the lacking elements can be supplied with confidence that the investment will pay off. Properly treated soils consistently produce above average yields. And whatever the crop, we can look to science for helpful developments. This is flame cultivation of one of our most important crops, cotton. As you will see, the weeds around the growing plant are simply burned out. In this basic crop, scenes like this of slow, tedious hand picking are becoming more rare as mechanical pickers and strippers take over the harvesting task. A tremendous surge toward mechanization and scientific farming is occurring in cotton, and indeed throughout southern agriculture. The contribution of science to agriculture is nowhere more evident than in the corn crop, which in the form of meat, milk, poultry, and eggs is the basis of the American diet. Hybrid corn is the result of years of intensive corn breeding work. By protecting the silks against random pollen carried on the breeze, and by capturing in a bag the pollen produced by the tassels, scientists can inbreed plants to intensify certain qualities and cross them to create new hybrid varieties. Corn breeding is building performance factors farmers want. Prominent among current projects is increasing the oil and therefore the protein content of corn. Such higher oil hybrids are already coming on the market. What developments the future holds, no one knows. But corn breeding is still a young science, and its magic work has barely begun. This detasseling scene, so well known to thousands of farm girls and boys, will soon become less familiar and may eventually become nothing but a memory. Pulling tassels will become less frequent because of a startling development in corn science. Detasseling makes sure that female or seed parent rows shed no pollen. But now, science is learning to do this job automatically by breeding a non-pollen shedding characteristic into seed parent plants. This tassel will not shed pollen, a brand new development in hybrid seed corn production. A limited amount of detasseling will still be necessary for blended seed production, but it seems certain that research in pollen restorers will eventually eliminate the detasseling operation in seed corn production fields. There's going to be less work on the farm, too, in raising corn. The mechanical corn picker, itself only made practical in the last 20 years by the development of hybrid corn, is already facing competition in the job of getting the corn out of the field and into the crib. In fact, the familiar crib itself may be starting on the long road to oblivion. The corn crib is a distinguishing landmark wherever corn is raised. But agricultural engineers have long known that storing and feeding ear corn was a good deal less efficient than working with shelled corn. Many farmers already shell some or all of their corn when it comes out of the field. The golden stream of kernels flowing into the wagon from the stationary sheller is a familiar sight, as is the growing mountain of cobs and husks on the other side of the sheller. But now a single field machine has been developed to do both the picking and shelling job. The picker sheller, or corn combine, for that's really what it is, moves down the row, shelling the corn right in the field as soon as it picks it. Now if someone would only invent a three-way combination that would not only pick it and shell it, but also dry it before it went in the wagon, well, maybe it'll come yet. A prime use of crops grown on American farms is livestock feed. The formula being fed here is a big step forward in utilizing farm waste products, for a large proportion of it is ground corn cobs. Cob meal, when properly supplemented, makes good cattle feed. Cattle, unlike humans, have the ability to digest feed with the high cellulose content. Supplemented cob meal may replace hay in the ration on many farms. As a matter of fact, cattle, both beef cattle and milk cows, are among man's oldest machines. For cows are converted, and Gertie, a 7-year-old Guernsey, has been letting scientists peer into her insides for some years now to show just how she does it. Gertie is popularly known as the cow with the window in her stomach. More exactly, she has a fistula opening into her rumen, a lucite apparatus which enables scientists to find out what goes on in this first of a cow's 4 stomachs. Gertie doesn't seem to mind this invasion of her privacy. She has calved once since the fistula was inserted and leads a normal life in every way. Periodically, the scientists check to see what's going on in Gertie's rumen. The reason a cow may be called one of man's oldest machines is that it consumes feed with a high proportion of inexpensive carbohydrates, much of it inedible by man, and turns it into milk and meat with a high proportion of expensive proteins. To accomplish this feat, a cow is equipped with a compound stomach, in which the rumen is, so to speak, the first stop, with a capacity of some 30 gallons. It is in the rumen that cellulose is broken down by bacteria. The rumen fluid being withdrawn will show about 10 billion bacteria per cubic centimeter. On every contraction of the rumen, the pressure squeezes the contents so that there is a constant mixing action of the microorganisms throughout the mass. Exact knowledge of the functioning of the rumen is leading to important savings in feed costs and perhaps other benefits, such as helping to solve the bloat problem. But whether the benefits are direct or in the distant future, science pushes ahead the frontier of knowledge. Many such projects seemed at first to have little immediate value, but led by and by to practical improvements welcomed by farmers. On the basis of these investigations, we are finding out how to get the bacteria in the rumen to work harder for us, unlocking the nutrients in low-cost feeds, and doing a better job on present roughages, such as grass or corn silage. Another possibility is the feeding of urea, a low-cost synthetic source of nitrogen. But at the moment, the scientist is not thinking of the eventual results of his research. He is intent on the job at hand. Similarly, most advances in scientific farming were once nothing but an abstract concept, a possibility. Artificial insemination was once only an idea, but today the dairy farmer has his choice of the finest pedigreed bulls to sire his herd. Dairy herd improvement through artificial insemination is an abundantly proved fact. Using artificial insemination from proved sires, a dairyman may raise his average butterfat production 75 pounds or more a year. The usual collection of semen per bull per week is about 5 or 6 cubic centimeters. This can be extended about 75 times without loss of effectiveness. Using 1 cubic centimeter per service, a single bull could service a theoretical total of over 23,000 cows a year, as compared with 30 to 50 cows bred per year by natural service. In this country, frozen semen is not yet available, but in England they are already breeding from semen that is a year or more old. The cost of artificial insemination is about $7 per service. The owner of 10 cows, for example, would pay $70 to have them all serviced. If he kept a bull of his own, the feed cost alone might be $100, not to mention the initial cost of a good bull. Semen is shipped refrigerated to a technician in each county. This entire Holstein herd is the product of artificial insemination and is one of the highest producing herds in Illinois. Average butterfat production is 548 pounds. The herd earned over $20,000 last year, and the owner was offered $12,000 for 3 of his cows, an eloquent testimonial to the value of breeding and herd improvement. One of the newer developments in dairy farming is pipeline milking, milk flowing automatically from cow to cooler. The system works by vacuum, the milk being sucked through the line to the bowl, and on from there, as we shall see, to the cold wall tank. The system is comparatively expensive at present, being used in the main by large operations, but it maintains highest quality and certainly eliminates the hard work in milking. Watch the vacuum work automatically. The system is cleaned without taking it apart by shooting detergent and then hot water through the lines. Better quality milk with less labor. Another promise of better farming through science. Diagnostic laboratories are the watchdogs of the livestock industry. Here, epidemic diseases are detected before they become widespread, a menace to health and an economic threat to a vital industry. Gastroenteritis, for which this 4-day-old pig is being examined, could infect a whole herd with a high mortality rate. 150 cases of anthrax have been diagnosed here at the clinic. It was traced to imported bone meal. As a result, all imported bone meal must now be sterilized. Brucellosis, called Bang's disease in cattle and Traum's disease in hogs, can affect man as well as livestock. These diluted blood samples are being tested for brucellosis. Together with samples from other suspected animals, they are placed in a centrifuge and whirled at high speed for 5 minutes. The centrifugal action separates the blood cells from the serum, as you can see in these samples taken from the centrifuge. Now the samples are ready for testing with Brucella antigen. Through the diagnostic laboratory, the university has detected diseases that were thought to be non-existent in this country. In addition to its testing work, the laboratory performs an average of 500 autopsies a month. Such laboratories are another example of our harvest of science, this time a harvest of health. Of the 500,000 known species of insects, 499,000 are, fortunately for us, respectable citizens who are not destructive to human interests. And many insects are beneficial. Our friend the bumblebee pollinates flowers and red clover. He doesn't know he's pollinating, of course. As far as he is concerned, a flower is simply an open-air restaurant. While the clear-winged moth is a cousin of the fellow in your closet, he thinks a cloth diet is silly, and, like the butterfly and the bee, is an agent of pollination. The butterfly, however, is frequently a reformed criminal who did attack plants when it was a larva. Only a few hundred species of insects are injurious, but they cause $3 billion damage each year. 9/10 of the animals in the world are insects. They are the oldest of the world's inhabitants. This is the larva of the cabbage butterfly, one of the pests who do so much damage in a vegetable garden. The corn borer is a highly expensive pest, frequently infesting entire areas. In a kind of division of labor, the borer attacks the ear and a caterpillar eats the leaf. Fortunately, in the balance of nature, an injurious insect is frequently a favorite dish of another insect. Here, for example, are some tent caterpillars going about their work. Here's a closer look. They don't realize that they're on the menu for today, but they are. Injurious insects attack many crops. This fellow's close relation, the locust, has been a plague since biblical times. But few crops have more enemies than cotton. Cotton starts off as a yellowish blossom which turns pink within 24 hours. The flower buds of the cotton plant are attacked by aphids, which stain the cotton and lower the grade. An enemy of the aphid is the lacewing fly, which also attacks bollworm eggs and small bollworm larvae. In certain sections, such as Texas, the bollworm is considered the greatest menace. One worm may eat 12 to 15 flower buds, or squares as they are called. The bollworm also attacks corn. In fact, prefers it to cotton. When the boll weevil, a long-nosed beetle, lays eggs or drills holes in the square or bud, the square drops off. Both larvae and adult weevils are destructive to cotton. The war against insects is an important part of modern agriculture. For centuries, farmers had to grow enough for both the bugs and themselves, and accept crop failures as they came. But here again, science is developing answers to the farmer's problem. The task of insect control proves both vast and complicated, as scientists in research laboratories probe for ever more efficient means of lowering the $3 billion annual damage bill. Many important insecticides have been discovered as a byproduct of other petroleum research projects. Commonly, every compound developed for whatever purpose is screened for insecticidal value. An example of the way promising new insecticides are tested is this chamber for evaluating oil-based livestock sprays and household fly sprays under standardized conditions. These flies are hatched and grown in the laboratory for the purpose of testing new sprays. 500 flies have been released in the chamber. The new insecticide is sprayed in measured amounts and pressure. Then the number of unparalyzed flies is counted, and the paralyzed flies are picked up with a vacuum device. They are held under standard conditions for 24 hours. After that period, the number of dead flies is compared with an official standard to determine how effective the insecticide is. These innocent-looking daisy-like plants contain pyrethrins deadly to certain insects at concentrations harmless to men and animals. For insects, these are deadly daisies. In quite another kind of laboratory, the good earth is made to contribute to the welfare of man in a new way. This tray contains a few of the more than 6,000 molds, yeasts, and types of bacteria classified at the Peoria Regional Laboratory of the United States Department of Agriculture in its search for microorganisms which produce newly recognized vitamins, chemicals, and antibiotics. This is Penicillium notatum, the mold discovered by Sir Alexander Fleming in England, raw material for the original penicillin. This is the famous mold found originally in a cantaloupe, from which all commercial penicillin is derived. All United States penicillin manufacturers started with cultures taken from this strain. Specimens in the collection provide visual interest as well as scientific value. Some of these have a proved value, others not. This is a citric acid producer, useful in soft drink manufacture and baking. This yeast is a producer of vitamin B2. The laboratory seeks microorganisms useful in industrial utilization of farm products. While penicillin molds, of which these are a few examples, are commonly thought of in connection with treatment of disease, some penicillin molds, like this Penicillium roqueforti, tells by its name that it is used in cheese making, as is Penicillium camemberti. Other laboratory investigations reveal culprits like this bacteria, which causes spoilage, and good friends in the bacteria world which produce things we need, such as vitamin B12. One of the remarkable developments of the work of the laboratory is dextran, which has replaced blood plasma. Dextran assumes either a taffy-like appearance, as here, or that of a powder or liquid. Dextran can be kept several years without refrigeration. It eliminates troubles which sometimes developed in plasma transfusions. Dextran does not replace whole blood. This amazing development is another example of turning an industrial waste of the sugar processing industry into a life-saving material. Another benefit from the harvest of science. Modern farming is a new way of life. Less and less do we depend on the random ways of nature. More and more do we seek to control and even create the factors making for successful farming. Making a farm pond illustrates well the new approach to farming. Here is an excellent conservation measure, a source of water in case of fire, a watering place for livestock, the foundation of a portable sprinkler irrigation system when nature skimps on rainfall or distributes it unevenly, and finally, a new recreational facility for farm families. Yet, within the new agriculture are still found those eternal values which will persist as long as man inhabits the planet. Farm youth looks forward, as their fathers and grandfathers did, to the agricultural fairs, an exciting part of the farming season. Today's youth brings to the competition in these fairs new knowledge, new techniques, finer animals and crops, and the urge to joy and laughter is eternally the special property of youth. Farming today is a new way of life, founded upon the oldest way of life. As the gladdest time of year approaches, modern agriculture comes nearer its goal of feeding a hungry world. Behind the abundance of today's harvests lies centuries of farming skill, combined now with the expanding frontier of scientific knowledge. Truly now, in the colors of the autumn, we see the ancient joys of harvest time mixed with the ever-growing ability of man to reshape the world nearer the heart's desire.